Okay, and in today's class will be 16th of July. Saturday. Okay, so in the last lecture, I told you guys that I will be discussing what is the reason and what is the rule. As we have Markovnikov's rule, there is also a rule for elimination. Okay, so it was given by a scientist. Okay, and he was a Russian scientist by the name of Zaitsev. Okay, his name as Zaitsev is written at like this. This is Zaitsev rule. Okay, so Zaitsev is pronounced as Setzev. Okay, so Setzev is it's Setzev's rule. Okay, it is written as Zaitsevs, but it is pronounced as Setzev rule. Okay, it was given by Alexander Zaitsev. It was a Russian chemist. Oh my God, Sayeda Rufia, you have been absent for so many days.
Yes, sir.
Okay. उसके बाद आपने कोई लेक्चर देखा ही नहीं फिर?
No, sir, I have to watch.
ठीक है, फिर आज क्लास में आप रहिए. I don't think you will be getting most of the things because अगर आपने नहीं देखा है lectures तो, okay?
Okay, sir.
Okay, but still you be in the class.
Okay.
Sets of rule. Right? During elimination reaction, during elimination reaction, hydrogen from that carbon is removed. Hydrogen from that carbon is removed. Which bears lesser number of hydrogens and forms more substituted alkene. Okay, so in a simple sentence, you will write in elimination, more substituted alkene is major product. Okay, let me know when you're done, guys. Done? Can I move on? Let me know if you are still writing. Now write a question. Reaction of alkyne halide with aqueous KOH give substitution and forms alcohol. But reaction with alcoholic KOH undergoes elimination and forms alkene. Explain. Okay, so this is a very important question for CBSE examinations. This have been asked many times directly. So you'll write the answer. Since alcoholic KOH, contains alkoxide ion, which is stronger base, it can eliminate hydrogen completely from beta carbon and forms alkene. But in aqueous KOH, hydroxyl ion is present, which is a weaker base, and good nucleophile. It is a good nucleophile. Hence, it cannot eliminate hydrogen from beta carbon and gives substitution reaction. Okay, so write this down. Important thing is what? The alkoxide ion which we have in alcoholic KOH, it is a stronger base. And if it is a base, then it has a tendency to what? Abstract hydrogen atoms. Okay, so what does base do? It abstracts hydrogen. And similarly, here we have hydroxyl ion. It is what? It is a weaker base and good nucleophile, and hence it cannot eliminate. Okay? Hence it cannot eliminate hydrogen from beta carbon. Write this down. This is the answer that you will write for CBSE. And then we'll see what is a strong base and what is a weak base, and why hydroxyl ion is a good nucleophile and alcoholic KOH, which gives alkoxide ion. Alkoxide ions, these are good base and strong base. Okay, so please write this down.
Done, sir.
Good. Let me know if anyone is still writing, okay?
Sir, can you scroll up? Hello? Sir? No, sir, can you scroll up?
Sorry? Is Akshay?
Okay, sir. No, I'm ready.
You have written.
No, sir, I'm writing. Writing the
Sure.
done, sir.
Great. Now, you see, I have a haloalkene. Please don't write anything, okay? It is like this. You have a carbon atom. It's bonded to another carbon atom. This carbon atom has a Br and 2 more hydrogens here. This has all of these 3 are hydrogen here. Now, if I take the case of alcoholic KOH, please don't write anything. Then here I have alkoxide ion, alkoxide. What is alkoxide? There will be an alkyl group and there will be oxide, okay? So just as hydroxide has HO negative, alkoxide will be RO negative. And generally we use the alcohol ethanol. So this RO negative is CH3, CH2, O negative. This is my alkoxide ion, and specifically speaking, this is ethoxide ion. So this is my electron-rich species. Now, if I use aqueous KOH, then my electron-rich species will be OH negative. It will be OH negative. Now, you guys will tell me which is larger in size, the alkoxide or the hydroxide, which is larger in size, OH negative or RO negative? This one is larger or this one? Yeah, correct. So what about others? Huh? Hamza, Kulsum, why are you guys not answering? Say the Rufia, ये तो आपको आ रहा होगा ना? Which is larger in size? Say the Rufia. Yes, Rufia. 1 or 2, which is larger? अरे yes sir क्या बोल रहे हैं आप? Please turn the mic on. Yes sir. I am asking something. लोग बोलते हैं yes sir. Rufia, please turn your mic on. Which is larger in size, 1 or 2? Which is larger in size, 1 or 2? Rufia, are you not present in the class? What happened? Hiba, tell me, which is larger in size, 1 or 2? Yes, Hiba, which is
1.
1 is larger in size. Okay. Rufia is not here or what? Okay. 1 is larger in size. Okay. Obviously, if 1 is larger in size, and see, here we have this as delta positive. Okay, this is delta positive. Now, it will be a bit difficult for this alkoxide ion to travel through all of these hydrogen and attack on this carbon atom. And that is why it does not attack here. Rather, it wants to attack on this hydrogen atom, because this hydrogen atom will also be having delta positive, because the electrons are being pulled from bromine from here and here and here. Okay, so all of the electrons will be pulled like this. So this will be also having delta positive charge. And also one more thing, CH3, CH2, it will be pumping electrons on the oxygen atom. That is why this oxygen will be having a greater charge than this OH negative here, because these are electron donating groups, and this will be pumping electrons to the O negative, and this will be very unstable, and it wants to react very fastly. It cannot hold on to make space and go and attack on this nucleophile. go and attack on this carbon atom and act as a nucleophile. What it will do, it will rather act as a base and it will attack on this hydrogen atom. Attack on this hydrogen atom. Hydrogen atom will leave with its electron like this. Okay, it will attack on this. No, sorry. Hydrogen atom will leave, but it will give its electron like this because O negative is already giving electron to hydrogen. So hydrogen does not need the electron which is present on the CH bond, and this Br will leave like this. So this is what happens when you have a very huge, when you have what? When you have large base, and when you have a base which is having high charge, the magnitude of charge is also high. So what happens if you have these two conditions met, then it will be elimination. But when you have a small base and the charge is low, it has low charge, then the probability of it acting as a nucleophile is always very high. Now, so OH negative, what it can do is, since it is small, it can easily travel through these hydrogens and it will attack on this Br. Sorry, it will attack on this Br containing carbon atom, and then the Br will leave. So it will give you nucleophilic substitution. Okay, so whenever you have strong base, it is going to give you what? It is going to give you elimination. But if you have a weak base, this weak base is also small, then it is going to give you substitution. Okay, so I hope this is clear why alcoholic KOH will give you elimination and aqueous KOH will give you substitution. Yes or no, guys? Please tell me. Krishna, Akshay.
Yes, sir.
Yes, sir.
Okay, fine. Now we'll move on. Please write reaction with metal. And reaction with metal, you will write the first reaction with magnesium. Reaction with magnesium. Please write. When alkane reacts with magnesium in the presence of dry ether. Okay, dry ether is what? Liquid or solid? Tell me, guys. Akshay, what do you think? Dry ether?
Solid.
Solid. Hamza? Dry ether will be solid or liquid? Yes, Hamza?
Sir, I guess liquid.
Liquid. Okay. What about Krishna? What do you think? Solid or liquid?
Solid, sir.
Solid. Okay. So see, ether is going to be liquid only. Okay. This dry means what? Absence of water. There is no water here. Okay. This dry, it represents what? The absence of water. So ether is always liquid, but there will be not even a slight moisture present when we are doing this reaction with magnesium. Okay. So in the presence, I am writing. I don't know why. Sorry. The presence of dry ether to form a compound with formula RMgX called Grignard reagent. Okay, so here we have R, then we have Mg, and then we have X. So this R part is what it is? Organic. This Mg part is metal. So this type of molecules, these are known as organometallic compound. they have a carbon bonded to a metal. Okay, and what is very unique about this type of molecules? Magnesium, since it is a metal, it will have a tendency to give electrons. And that is why here the Mg will have delta positive and R will have delta negative and very high delta negative charge. Magnesium, it not only have a tendency to give electrons, it loses its electron. It wants to lose its electrons always if you have anything which is more electronegative. Okay, so here this R will have a high negative charge, and which is quite rare in organic chemistry. Whatever molecules we see in organic chemistry, these molecules are what? Carbon, hydrogen, oxygen, nitrogen, and then the halogens. Now, other than carbon, we have hydrogen, which is having similar electronegativity as that of carbon. The other molecules are halogens, higher electronegativity, oxygen, higher electronegativity, nitrogen, higher electronegativity, right? So at most of the times, the carbon atom, it always have a delta positive charge. But in this case, when we have organometallic compound, the carbon has delta negative charge, and this type of compounds, these are very useful if I have any electrophile, then this electrophile can be attacked by this alkyl group and it can form a bond. Okay, so please write this down. I hope you guys are done, right? You all
Yes,
have
sir.
written this? Yes,
Yes,
no?
sir.
Yes, no? Okay, no one is writing. Please write next. We'll write some reactions, Rx plus Mg. So the reaction happens like this. We have Rx plus Mg. It is going to give you R Mg X. So if I have CH3, CH2Br, it's going to give me plus Mg. Achha, here it will be dry ether, okay? It will give me CH3, CH2, Mg, Br. So it is named as ethyl magnesium bromide. Suppose we have something like this. Benzene ring. So we have haloarene, and we are reacting this with Mg. I will be getting MgBr. So this will be phenyl magnesium bromide. Check. Done, everyone? Yes or no? Please tell me.
Done, sir.
Done. All right, a question which is also very important. Grignard reagent is always prepared in anhydrous conditions. Explain. Okay. So why it is always prepared in anhydrous condition. You write the answer. Okay, you write the answer. Since Grignard reagent is very reactive, in nature, due to which it reacts even with moisture and forms alkene. Okay. So if I have CS3 MgBr and I'm preparing this in the presence of what water. So after the reaction with, what will happen? If I have, let us say, CH3Br and then there is Mg and there is also some water. Okay. So what is going to happen? You will form first of all CH3 MgBr. Then what we have? We have water. What's water? It is HOH, where this H is having delta positive. And this CH3, now due to the presence of magnesium, it will have delta negative charge. And this magnesium, sorry, this CH3 negative, it will attack on this hydrogen and it will form CH3H. What is this? This is alkane. This is now methane. We have methyl bromide, which formed methyl magnesium bromide. And then in the presence of water, what it will form? It will form alkane. So there is no use. And we will be getting no Grignard reagent if I have water. Okay, that is why what happens. We don't have any water and we prepare this in the anhydrous conditions. Okay, and plus you will get MgBrOH. Okay, MgBrOH. Done, guys?
Done, sir.
Done, sir.
Okay. 1 minute. Or done?
Done, sir.
Done. Okay. Thank you. Right, next. The reaction with sodium. So we'll study 3 reactions here. The first reaction is, all of these 3 reactions are named reaction. So write the first reaction, Wood's reaction. Okay, please write with me. When two same haloalkane reacts with sodium in the presence of dry ether, they form alkenes containing double the number of carbon atom. Double the number of carbon atom, and the reaction is called Wood's reaction. So you'll have Rx okay, we'll have 2 sodium and also 1 more Rx. What happens? So this will form 2 NaX and this R and R, they will combine. Also, this is in the presence of dry ether.
Done, sir.
Done. Okay. So let's get a quick look on the mechanism. Okay. So originally it is having a single electron transfer SET type mechanism, but you don't have to study SET type mechanism. Okay. So let me just get this a bit easy for you guys. So if we have sodium atom, this two sodium atom, what they will do? They will give you two sodium plus ions, and they will give you two electrons. Now, one of the haloalkane Rx, it will react with this two electron. And we all know this is delta positive, this is delta negative. So this two electron, they will attack on this carbon atom. Okay, so, and then the halogen atom will leave, and then the halogen atom will leave. So you will be getting this two electron will attack here. This halogen will leave. So we'll get R negative plus X negative. So how is this making sense? Yeah, it is making sense. First of all, you can see there are two negative charges in the reactant, two negative charge in the product also. So it does make sense. And also, this particular R group, it is losing one of its electron, right? The halogen is taking the electron, but it is getting two electrons, right? So it is compensated with one electron, and it is getting the negative charge from the other electron. Okay. So when we have R negative and X negative, after this, what will happen? This R negative from here, it will attack on this Rx, because we have one more Rx. Here we have delta positive, here we have delta negative. Obviously, this R is going to attack on this R, and you will be getting an RR bond plus X negative. Okay. So as you can see, this two electron has been consumed, this R negative has been consumed, and it's formed RR. This 2NaX, it will react with X negative, and it will form 2NaX. Okay. This 2Na positive, it will react with X negative, it will form 2NaX. Is that understood? Yes or no, please tell me. Simple mechanism.
Yes.
Yes, sir.
Yeah. Okay. Write this down, then we'll write some questions. For these two, please make the product. I shall also try for this one. You have to send the answers on WhatsApp. Also, let me know if you are getting stuck somewhere. Okay. Akshay is done. Send the answers on WhatsApp. Say the so Rupia, I think you have my WhatsApp number, right? Yeah. Krishna, correct, correct, correct. Akshay, correct, correct, correct. Hamza, Heba, Kulsum, and Sayyida Rupia waiting for you guys. Yes, Hamza, what happened?
Sir, I'm still doing it.
Still doing? Kulsum, what about you?
I'm done, sir. I'm sending it.
Okay. Hamza, can you send whatever you have done till now? Same goes for Kulsum. Kulsum, I have not received your answer. Hamza, can you please send whatever you have done till now?
Yes, sir. Sending it.
Kulsum?
I have sent it, sir.
हाँ send it. हाँ, हाँ, ठीक है, अभी मिल गया. ठीक है. अब यहाँ पे देखिए आप लोग. Hamza, Hamza and Kulsum, can you please turn your mic on, both of you?
Yes.
What is the R here? What is the R? ये फॉर्मूला हम लोग ने रिएक्शन ये लिखा है ना. When we have 2RX plus Na in the presence of dry ether, I will get RR. Yes or no, Kulsum?
Yes.
Yes, sir.
Yes. What is the R here?
CH3.
Yes. Yes.
What will be the product then? Product क्या होगा?
CH3,
CH3. तो फिर आप लोगों ने क्या लिखा है? हाँ, Hamza, Kulsum. Similarly here also, this CH3, CH2, and then this CH2, CH3. यहाँ पे आपके पास जो भी मॉलिक्यूल है ना, ये कार्बन जो है उसको आप दो बार बस ये दो प्रोडक्ट बनाइए ऐसे. डबल द नंबर ऑफ कार्बन एटम. इसमें आप लोग को इतनी तकलीफ हो गई. Right. The next question, fourth one. In this you have CH3, CH, CH3, and there is a Br in the second carbon. Whenever you have branch, please listen, don't write anything down. Whenever you have a branch, then see what is going to happen. This Br will leave, the 2 electrons will give negative charge here, and this is going to attack the same molecule, okay? So you will write this molecule like this, CH3, CH, CH3, and then you will face the carbon atoms which are having halogen just in front of them. दो molecule बना लिया आपने, and then you are facing the carbon atoms containing halogen just in front of them, okay, face to face, and then you make a bond like this. Okay, then you make a bond like this. If you get any question from here, then you can easily make it now. Let us say you have something like this, and there's a Br here. So what you will do, in the presence of Na and same dry ether, then you will make this 2 times. One time like this, and then this carbon is having the Br, then you will make another molecule like this. This carbon is having Br, and then you will join them. No matter how complex you are given, you will do always the same thing. If you have a Br here plus Na, then what you are going to do? You are going to make this product like this, okay? And then इसका जो mirror image है ना, बस उसको बना दीजिए ऐसे, 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 and then you join these two. Just identify the carbon which is having, this carbon is having Br, this carbon is having Br, and इसका mirror image बना के just join them. It doesn't matter what they are going to give you. I can keep on giving, even if it is very simple example. For example, CS3, Br plus Na. So write CS3, and then you will write. You will again write what? H3C. ऐसा ही लिख दीजिए. दोनों का bond बना दीजिए. Whatever is given, it doesn't even matter. If you have been given something like this, Br, and then there is a CS3 group here, plus Na. Then you will make this molecule like this. You remove the Br, CS3, and then you will make the same mirror image. Mirror image का मतलब क्या होता है? If the CS3 is near, this will be mirror. उसमें आपके पास CH3 नजदीक ही रहेगा यहाँ पे। have CH3 here, ये दोनों CH3 बॉन्ड नहीं करेंगे, बस ये ध्यान रखिएगा। तो इसको हम ऐसे बना दे रहे हैं, both of these means CH3 are there, and then what will happen, we'll have a bond between these two carbon atoms. इस कार्बन के पास ब्रोमीन था, इस कार्बन के पास ब्रोमीन, just make a bond. Stop here. All of these have dry ether, okay?
Done, sir.
Okay, all right, next. We'll write tertiary haloalkene. Data point. Did we write about tertiary haloalkene? No. Okay, write some remarks. First, we will write this reaction is not applicable for two different haloalkane, because it gives mixture of alkane which is difficult to separate. Now, what it is saying that if I have, let us say Rx, let us say CH3 Br plus I have CH3 CH2 Br plus 2 sodium atoms in the presence of dry ether. Now, when I have this case, then it doesn't mean that I have only one molecule of CH3Br, right? I have many molecules of Br, but many molecules of CH3Br, but they are in the proportion 1:1:2. Now, what can happen? I can get some product in which CH3 will react and then to form CH3. In some case, what will happen? CH3 will form a bond with CH2, and in some case, what is going to happen? The CH3, the ethyls are going to react and they can form CH3, and then CH3. As you can see that this is a mixture, and then separation of this mixture will be very tough because the boiling point, we always separate through distillation generally. Okay, and what is the physical property that is different, the boiling point is different. And if the boiling point will not be different, then it is not going to separate easily. And that is why we don't do two different haloalkanes. We always have two same haloalkanes so that we don't get any mixture. Okay, so write this down. These are the combination that you can produce if you have different haloalkane. Done everyone, yes or no?
Done, sir.
Done. Anyone still writing? No. Wait, next. This is the first remark, and then the second remark is Wood's reaction is not given by tertiary haloalkanes. Why is it not given by tertiary haloalkanes? See, we have CS3, CS3, CS3X. Okay. Now it will react with what? 2Na. Now what will happen? 2Na will give it electron and it will become CS3, C, CS3M, CS3. Please listen, don't write negative. Now further, this has to react with what? It has to react with CS3, CS3, a halogen atom, and then CS3 as per mechanism. And this has to attack this carbon atom. Now, what do you think? Is this attack possible with all of these methyl groups? No. And obviously, this electron-rich species is also very large. This substrate is also very large. This haloalkane is also very large, and that is why what will happen? Rather than attacking on the carbon atom, this C negative, which is electron-rich, it will act as a base. And what it will do, it will abstract one of the hydrogen because it cannot go through all of these CS3 molecules and attack on this carbon atom. This attack is not feasible. This attack is not going to happen. If this attack would have happened, then it would have shown Wood's reaction. But this does not happen. This reaction happens and abstract the hydrogen and it forms. This will get CH2, double bond. Okay. CH2 and then double bond. And what product will you get from here? CH3, and this halogen will be gone from here and you will be getting CS3. Okay, so this is the product that you are going to get if you are doing Wood's reaction in the presence of sodium. Okay, in the presence of sodium, it will form 2NaX. Okay, so Wood's reaction is not given by tertiary haloalkanes since it undergoes elimination and gives alkene as major product. Because this CS3 gives electron here like this hydrogen, electron here, this X negative will leave like here.
Done, sir.
Done? Okay. No. Very similar to this reaction is fatigue reaction. Just a second. What's reaction? Second is fatigue reaction. Now in fatigue reaction, we use haloarene. Okay, and words we are using haloalkane. So please write when two same haloarenes react with sodium in the presence of dry ether. Dry ether to form biphenyl is called fatigue reaction. Have two molecules of haloarene, two sodium atoms, the presence of dry ether, you will be forming biphenyl. For example, if you write okay. So in this, you can get at least two conversions. One is 1-chlorobutane to N-octane, and one is benzene to biphenyl. Okay. So one more thing. If you see diphenyl, then don't get confused. Diphenyl and biphenyl both are the same thing. Okay, both are same thing. Right, first 1-chlorobutane to normal octane, N-octane. 1-chlorobutane is 1, 2, 3, 4 chlorine. I have to convert this to 4 carbons, 5, 6, 7, 8 carbons. So I hope you can see very easily. It is just a normal Wurtz reaction, right? So this will be in the presence of sodium and dry ether. Similarly, benzene 2. There are two questions, okay, in in CRT. One is biphenyl, and then there is benzene to diphenyl. Okay, diphenyl. Both are same things. Diphenyl and biphenyl both are same things. I don't know why they have given separately. So we have benzene. First benzene किसमें convert करेंगे हम लोग? Haloalkane. Okay. So we have benzene. I am not able to make sense properly. Benzene. In the presence of reacts with Cl2, the presence of FeCl3 or AlCl3, it will form chlorobenzene. React with this sodium, presence of dry ether, and will be forming biphenyl. Then लिख लिया आप लोगों ने?
Done, sir.
Okay. Now the last third reaction. Okay. This was fatigue. Third reactions of with sodium is Woods fatigue. It is a combination of fatigue and Woods fatigue. Woods fatigue reaction. So what happens? Please read. When one molecule of haloalkane and one molecule of haloarene reacts with sodium in the presence of dry ether to form alkyl benzene. Alkyl benzene is called Woods fatigue reaction. ठीक है, तो इसमें क्या होगा? You will have a haloarene plus a haloalkane, presence of sodium and dry ether will be forming alkyl benzene. Okay, so if I have, let us say, chlorobenzene plus methyl chloride, the presence of sodium and dry ether, I will be forming. Let's see. Please write this down. Done everyone? Yes or no? Please tell me.
Done, sir.
Done, sir.
So see the chemical properties of haloalkene, it is almost done. Chemical properties of haloarene is left. In those we have mostly what? Okay. Haloarene will be Wurtz fatigue and fatigue. These are from haloarenes. And most of the reactions of haloarenes are electrophilic substitution reactions that we can cover in one class. Okay. So we have some time left. Let us do some conversions. I think conversions में आप लोग काफी दिक्कत होती है. Okay, so we'll do one. एक-एक करके करेंगे सब कुछ. Okay. Now I have told you guys. Or did I told you? No. I think I have not told you guys. Whenever you are doing conversions, you will ask first of all. अभी आप haloalkane haloarene का कर रहे हैं ना? So you will always ask for each chapter what is the chapter's name. Okay, and see you have a propane 1-ol, but 1-ine, 2-bromopropane. All of these are targets. Okay, all of these are targets. Second, you will ask yourself, is the target? Then you will ask, can the target be prepared from जो भी चैप्टर का नाम है. ठीक है, चलिए फर्स्ट का जवाब बताइए आपकी क्या है. व्हाट इज द फर्स्ट आंसर? व्हाट इज द चैप्टर्स नेम? अभी क्या चैप्टर चल रहा है बताइए.
So haloalkanes and haloarenes.
वेरी गुड. ठीक है, haloalkane haloarene. Then what will be the second question that you will ask? Can the target, ब्रैकेट में हमने क्लास लिखा है. When I write class ना, it is what it is. I'm talking about the class here. Propane 1-ol. That means can I prepare alcohol from haloalkane? Can the target, that means can alcohol be prepared from haloalkane? ठीक है, यहाँ पे क्या है? But 1-ine. So whenever you have double bond or triple bond, you will call this as unsaturation. And you will ask yourself, can unsaturation be prepared from haloalkane haloarene? यानी double bond triple bond कभी बनता है या नहीं बनता? Don't focus on triple bond. ठीक है, you just focus on unsaturation. If we can do unsaturation once, we can do unsaturation twice also, and then we will get the triple bond. Okay. Now you are here having here 1 bromopropane to 2 bromopropane. So you will ask, can the target be prepared from the target? That means haloalkane से haloalkane जाता है या नहीं जाता? You will write it like this. Okay. चलिए. So tell me guys, for the first case, can alcohol be prepared from haloalkane? Yes or no? Tell me.
Yes.
Yes. What is the reaction? Tell me. RX reagent क्या होगा? और उसके बाद अल्कोहल तो आपके पास है ही ROH, ऐसे लिखिएगा. ठीक है. Don't focus on the specifics right now. What is the reagent that you will be using? Tell me. What is the reagent that you will be using? अरे यस बोल के बस. हाँ टेल मी, क्या बताइए अक्षय? नहीं कृष्णा ना,
Sir,
कृष्णा बताइए.
KOH.
हाँ कौन सा KOH? अल्कोहलिक या एक्वस?
Aqueous.
एक्वस KOH आज ही किया ना हम लोगों ने. हमजा आपका जवाब क्यों नहीं आ रहा है? हमजा आपने पढ़ना बंद कर दिया क्या? हमजा ऐसे मत कीजिए प्लीज. हमजा, हमजा आर यू
Yes.
देयर?
Yes.
आप जवाब बिल्कुल भी नहीं दे रहे हैं अब तो. हाँ नहीं आ रहा क्या आपको? ऊपर से जा रहा है?
No, sir.
नो ना, तो फिर आंसर तो दीजिए. ऐसे शांत क्यों हो गए आप बिल्कुल? ओके, सो विल यूज एक्वस KOH. ठीक है, इतना कर दिया आपने, एक स्टेप आपका हो गया. ठीक है, देन वंस यू हैव आइडेंटिफाइड दिस, यू व्हाट यू विल डू? थर्ड, can the starting material okay, wait a second, अगर ask यहाँ पे जो भी आपको मिला है ना, ये RX मिला है आपको, then you will ask yourself, can the chapter's name be prepared from starting material? ठीक है, तो स्टार्टिंग मटेरियल क्या है आपका? एल्कीन है. हम ये पूछना चाह रहे हैं, एल्कीन से हैलो एल्कीन बन सकता है या नहीं बन सकता है? इज इट पॉसिबल? टेल मी. कैन यू प्रिपेयर हैलो एल्कीन फ्रॉम एल्कीन्स?
Yes.
Yes, we can prepare. Okay, what are the reagents that I can use?
Palladium, platinum, platinum.
मान जाइएगा अक्षय, आप चैप्टर देखिए, पेजेस फ्लिप कीजिए, प्रिपरेशन ऑफ हैलो एल्कीन में जाके देखिए.
Okay.
ऐसे ऊपर से बोल रहा है पलेडियम प्लैटिनम. अभी तक पलेडियम प्लैटिनम आया नहीं है चैप्टर में, एक दफा भी हमने लिखा नहीं है.
Okay, from this chapter. Okay.
अरे फ्रॉम दिस चैप्टर क्या बात है? हैलो एल्कीन हम लोग बना रहे हैं ना, तो हैलो एल्कीन तो यही चैप्टर है, लेकिन एल्कीन से हैलो एल्कीन बनाना है. कोई भी चैप्टर हो, हम ये नहीं बोल रहे हैं, लेकिन पलेडियम प्लैटिनम तो होता अगर हैलो एल्कीन बनाने के लिए यूज, तो होता ना प्रिपरेशन में, मेथड ऑफ प्रिपरेशन. लुक एट द मेथड ऑफ प्रिपरेशन, टेल मी व्हाट इज द रिएजेंट. हाउ कैन वी प्रिपेयर हैलो एल्कीन फ्रॉम एल्कीन? Flip some pages, go to the method of preparation. क्या किसी को नहीं मिल रहा? कृष्णा, हमजा, कुलसुम.
So like HP.
अच्छा, तो साफ साफ बोलिए, व्हाट आर यू सेइंग?
For Aqueous.
नहीं आ रही. Once again, please. I heard
HBr. HX.
HBr. HBr is okay, fine. Now we can prepare this. Okay, okay. Now we have got propene. Okay, we have got propene. अब यहाँ पे आप बताइए, एल्कीन से हमने क्या किया? प्रोपीन. तो बताइए क्या प्रोडक्ट बनेगा? ये बनेगा या ये बनेगा? सॉरी, दोनों तो सेम बना दिया हमने. ये बनेगा या फिर आपके पास ये बनेगा? कौन सा बनेगा आपके पास?
First one.
फर्स्ट वन, राइट?
Yes.
ठीक है, अब इसके आगे हमको क्या कराना है? एक्वस KOH करा दे, तो क्या बन जाएगा? इज इट द टारगेट? टेल मी, टारगेट यही है क्या? लुक एट द नेम एंड लुक एट द स्ट्रक्चर.
No, sir.
इज द टारगेट
No.
सेम?
No.
सो व्हाट वी हैव टू डू? टेल मी, क्या चेंज करना
Just
पड़ेगा
second.
यहाँ पे? सॉरी,
So position of alcohol.
अरे नहीं रिएजेंट्स में क्या चेंज करना पड़ेगा? पोजीशन ऑफ अल्कोहल तो हम चेंज नहीं कर सकते ना, रिएजेंट में क्या चेंज करना पड़ेगा बताइए?
The beer will be position of beer.
सॉरी नहीं रिएजेंट में हमने क्या क्या रिएजेंट यूज किया है? HBr यूज किया है, aqueous KH यूज किया है ना?
Yes.
तो मतलब रिएजेंट चेंज करेंगे तभी तो हमारे प्रोडक्ट्स में चेंज आएगा. सो टेल मी व्हाट रिएजेंट शुड आई यूज? आई हैव टू प्रिपेयर दिस राइट. उसके बाद aqueous KH अगर हम कर लेते हैं तो ये बन जाएगा. बताइए. नहीं याद किसी को? देयर आर टू मेथड्स ना भाई HBr यूज करने के, इसीलिए हम बोले थे. हाउ मेनी ऑफ यू हैव गॉट दिस टाइप ऑफ थिंग? किसी ने कुछ इस तरह का बनाया है? हाँ, ऐसा किसी ने बनाया है? टेल मी.
Yes, sir.
है ना? तो उसमें तो लिखा होगा ना आप लोगों ने, जब एल्कीन होता है तो फिर हम लोग दो चीज यूज कर सकते हैं HBr के साथ. नहीं लिखा? अगर हम पेरोक्साइड यूज करेंगे, याद आया कुछ? नहीं याद आया?
Yes, sir. Anti-Marconi.
Then I will be adding the anti-Markovnikov addition, right?
Yes.
ठीक है. अक्षय, हमजा, टेल मी. अब समझ में आया कैसे करना है?
Yes, sir.
Yes, sir.
ठीक है. You will have a problem when you have this type of thing. जब इस तरह का आएगा ना तो अब इसको अब चलिए ठीक है, ये करते हैं, सेकंड वाला करते हैं. इसको छापिए पहले आप. Done guys? Yes or no? Please tell me.
No, sir. Just a minute.
Done, sir.
Done. Sure. हमजा, बस हम ये सवाल करके खत्म कर लेंगे. So maybe you can watch the lecture. What do you think, Hamza?
Sir, like the next question after the next question,
Sorry.
like when will you end the class after the next question?
After the next question, you will be.
Sir, I'm asking when will you end the class? Like after the next
I
question?
will end the class. I will end the class after the next.
Okay.
Okay.
Okay, sir.
ठीक है. So look at this question. Ethanol to bute 1-ine. Okay. Ethanol to bute 1-ine. Now you know this requires something from your 11th standard here. Okay, that is why they have given this ethanol to bute 1-ine. So see what is going to happen first of all. Ethanol. What is ethanol? CH3, CH2, OH, 2, bute 1-ine. So it will be CH triple bond C, single bond CH2, CH3, single bond CH2, and then CH3. Now see. First, what we can do? There are many ways in which we can go to. This is going to be a bit long, but please bear with me, okay? So what we can do here, I can start with SOCl2. I will be getting CH3, CH2, Cl. After this, what I can do, I can do dehydrohalogenation using alcoholic KOH. I will be getting CH2, double bond CH2. Now, once I have got this, I can add halogen. If you remember, preparation of haloalkane from alkene, in that we have done. If I add Br2, I will get vicinal CH2, CH2, one Br here, one Br here. Okay. Now, once you add alcoholic KOH, then what is going to happen? Once the bromine will removed from here, the hydrogen will be removed from here. Then the bromine will be removed from here, and hydrogen will be removed from here, and you will be getting alcoholic KOH. Okay, so alcoholic KOH में देखिए एक प्रोडक्ट आपको क्या मिलेगा? CH3, CH2Br, ठीक है. यहाँ से आपके पास एक बार Br निकलेगा, यहाँ से हाइड्रोजन निकलेगा, यहाँ से Br निकलेगा, यहाँ से हाइड्रोजन निकलेगा. So you will get CH triple bond CH. ठीक है. So once you have got CH triple bond CH, then you can add here NaNH2, sodium amide. Now what the sodium amide does, it abstracts the hydrogen, this NH2, it abstracts the hydrogen and it forms NH3. And you get C triple bond C. Both of these are negative charge, sodium and sodium. Once you have prepared this, you have got negative charge, what you can do? You can use CS3I. Now CS3I will easily dissociate and you will use two molecules of CS3I. One of the molecule of CS3I, what it will do? But 1 ion है, but 2 ion है. Oh, okay. You have your but 1 ion. I was thinking I have but 2 ion. ठीक है. ये but 2 ion के लिए हो जाएगा. Okay, so I will make here CH3, C triple bond C, CH3. ठीक है. ये आपको but 2 ion के लिए लिख लीजिए तो. For but 1 ion it will be different. C and CH3. There will be just a slight change here. Okay. So see, the only change that you are going to do is from here. Everything will be same. From here you will add. यहाँ पे आपको दो part में डालना पड़ा था. Here you will add only one part of NaNH2, one equivalent. And from here you will be getting CH triple bond C negative and Na positive. यहाँ से सेम है, बस आपके पास CH3 CH2I हो जाएगा. So here this carbon will attack on this CH2 and you will be getting CH3, ये CH2. This will be attacked with the C triple bond CH. ये आपका but 1 ion हो जाएगा. This is going to be a but 2 ion. So the only difference is of the CH3I, and here we will be using CH3 CH2I. Write this down. The ones which are using 11th standard knowledge, they will be a bit less. There will be very less, I would say. Bit less का बहुत ही कम होते हैं वो. Done everyone? Yes or no? Tell me.
Just a minute, sir.
Okay. And don't worry, we'll do all the conversions that you have in the Haloalkane Haloarene chapter. Okay. So you have at least, I think, somewhere around 30 conversions. जिसमें से कुछ same है. Okay, there are some same. So around more than 25 you already have. Done.
Done, sir.
Okay. एक last वाला भी देख लीजिए आप बस. In this you will recognize the reactions. Okay, 1 bromopropane to 2 bromopropane. Okay, so in this reaction what is going to happen? 1 bromopropane है आपके पास, उसको 2 ब्रोमो करना है, ठीक है. तो 1 और 2 का जब भी आपके पास सीन हो ना, whenever you have 1 or 2, then you will always say that there will be somewhere used the Markovnikov anti-Markovnikov वाला लोचा कहीं ना कहीं पे होने वाला है. Okay, so you will always start with, you will have somewhere around alkene will be present. Okay, somewhere alkene will be present, and then only you can do some kind of substitution like this. ठीक है, क्योंकि आप ये देखिए ना, you have 1 bromopropane और आपको इस कार्बन पे लेके आना है. तो यहाँ पे पहले अगर हम डबल बॉन्ड ले आए, है ना, इससे हम डबल बॉन्ड ला सकते हैं और डबल बॉन्ड के बाद हम ये वाला रिएक्शन कर सकते हैं कि यहाँ पे आ जाए. So see, this is going to be very easy. First, what we are going to do, Br लिया हमने, Br से हम क्या करेंगे, alcoholic KOH. Now this Br has only one adjacent carbon, which is this carbon here. So इन दोनों के बीच में double bond. After this, what we are going to do, here we are going to use HBr in dark. ठीक है, dark मतलब peroxide नहीं है. So you'll get a Markovnikov product like this, Br. You guys recognize the reaction now? Yes or no?
Yes, sir.
Yes.
Okay. Write this down. जब भी 1-2 का लोचा हो ना, देखिए जैसे एक और रिएक्शन है, 2 क्लोरोप्रोपेन to 1 propanol. यहाँ पे भी same you will have you will first of all make alkene, 2 chloropropane Cl, alcoholic KOH, you will make a double bond, then you will prepare HBr, in the presence of peroxide or light you will be forming Br here. अब उसके बाद aqueous KOH, सीधा आपको क्या मिल जाएगा, Br की जगह OH. देखिए 2 था, 2 chloropropane, now it is 1. So once you start doing this type of things ना, then क्या होगा, then you will start recognizing some patterns, फिर उसके बाद आपको आ जाएगा. चलिए, that is it. I'm sorry Hamza, took 6 minutes more. Copy
No
this down.
problems.
अच्छा, one more thing. कल टेस्ट है आप लोगों का, टॉपिक लिख लीजिए. You will be chemical properties. Okay. Till today's class. एसेंस आप स्टार्ट कीजिएगा न्यूक्लियोफिलिक सब्स्टिट्यूशन से लेके आज तक की क्लास का सब कुछ पूछा जाएगा. ओके, एंड टुमारो यू विल हैव 1.5 hour लेक्चर एंड देन 30 minutes टेस्ट. ठीक है, चलिए. Thank you guys. Thank you very much. If you have not written this one, it's okay. Okay, I will be discussing this once again. जब conversions पे से करा रहे होंगे तो. Okay. चलिए. Thank you guys. Thank you very much.